Mars has suffered for centuries from the poetry of distance. It glows in the night sky with a color that invites projection, a red point suspended between omen and destination, near enough to the imagination to feel almost personal, and far enough from Earth to absorb every fantasy of renewal. People have looked at it and seen war, prophecy, canals, conquest, escape, a second home, a waiting frontier. That is part of its power. Mars does not appear as a random stone in darkness. It appears as a world with attitude, a place whose very color suggests unfinished meaning. Yet the first city on Mars, if it is ever built, would not begin as a noble answer to wonder. It would begin as an engineering enclosure standing against a lethal environment. The dream of red horizons and two small moons crossing a foreign sky contains a truth, but only a partial one. The deeper truth is harder. Mars is not generous. Its atmosphere is too thin to protect or sustain the human body. Its cold is severe. Its dust is pervasive. Its radiation burden is serious. Its distance from Earth turns ordinary resupply into a major interplanetary operation. A city there would not be the extension of earthly urban life into a new landscape. It would be a survival machine that had learned through extraordinary labor how to imitate a few narrow conditions of home. That is what makes the subject so unsettling. The phrase "first city" suggests streets, neighborhoods, routine, memory, children, kitchens, repairs, quarrels, schools, waste systems, power grids, local politics, ordinary fatigue, maybe even boredom. But on Mars, every one of those things would still be hanging from the thread of life support. The city would need to appear normal enough for people to endure it psychologically, while remaining abnormal in every physical sense. Outside its boundaries, natural human survival would end quickly. Inside them, survival would continue only because countless systems kept winning their argument against a hostile world. The journey to Mars would already separate the Enterprise from all familiar conquest. A first city cannot be imagined honestly without remembering that its founders must first cross interplanetary space. Mars is not next door. Even at favorable launch windows, it lies far enough away that transit takes months rather than days, and those months would be spent inside a vessel exposed to radiation, confinement, delay, technical fragility, and the accumulated psychological strain of moving toward a place from which easy return is impossible. This matters because the first city would not be founded by fresh explorers stepping from a short and triumphant commute. It would be founded by people already altered by the voyage. They would arrive with months of confinement behind them, with bodies and minds carrying the imprint of transit, and with the knowledge that every piece of machinery that delivered them must now be integrated into a broader architecture of settlement or else become waste on an unforgiving world. A mission to Mars is often imagined with the destination as its emotional center. In reality, the voyage itself would already have begun the work of psychological transformation. There is a darker implication as well. On Earth, danger is often balanced by the possibility of retreat. On Mars, that balance weakens dramatically. Launch opportunities depend on orbital timing. Communication is delayed. Emergency evacuation cannot be treated as a practical assumption. Once a crew commits to settlement, it steps into a regime where error has much more time to deepen before help can arrive, if help can arrive at all. The city would therefore begin with a truth that no ordinary city on Earth has ever had to absorb so completely. It exists at meaningful remove from rescue. The Martian surface itself would shatter the comforting fantasy almost at once. The sky may sometimes appear butterscotch or dimly pink with suspended dust, but its atmosphere is so thin that it offers almost none of the protections human beings take for granted. It cannot be breathed. It cannot meaningfully slow harmful radiation the way Earth's atmosphere does. It cannot keep liquid water stable at the surface for long under ordinary conditions. It cannot hold warmth through the night with anything like terrestrial generosity. Mars has air in a technical sense, but not in a human sense. To step outside without protection would not feel like entering a harsh desert. It would feel like entering a place that had forgotten the basic contract of life. That distinction is crucial. The deserts of Earth can kill, but they still belong to a biosphere. Mars does not. A human being on the Martian surface without a pressurized suit would not merely be uncomfortable. They would be confronting vacuum-adjacent pressure, frigid temperatures, and the immediate collapse of the conditions under which the body ordinarily functions. The first city would therefore not be built on a frontier in the old mythic sense. It would be built inside an environment closer to a permanent external hazard field. This is why settlement architecture matters so profoundly in any serious Martian scenario. Habitats, tunnels, buried modules, radiation shelters, pressure compartments, power systems, water recovery loops, air processors, and emergency reserves would not be conveniences enabling a comfortable outpost. They would be the only reason the city deserves the word city at all. Without them, Mars is not urban land awaiting development. It is a planet where urbanity must be manufactured from first principles against the grain of nature. Radiation would shape daily life more than most romantic depictions admit. Earth protects its inhabitants through a thick atmosphere and a magnetic field. Mars offers far less shelter. Its atmosphere is thin, and it lacks a global magnetic field comparable to Earth's. This means the first city on Mars could not simply spread itself across the surface in elegant, transparent domes if it intended to survive for years. The most sensible long-term designs tend toward burial, regolith shielding, thick-walled structures, caves, lava tubes, or other means of placing substantial mass between people and the sky. That already changes the emotional character of the settlement. The first enduring city would probably not look like a radiant open garden under the stars. It might feel more like a fortified interior hidden inside the ground, lit artificially, engineered for defense rather than spectacle. There is a psychological cost to that realism. Human beings dream of living on another world by imagining the view. The safer Martian city may have to deny much of that view most of the time. Its inhabitants could come to know Mars less as a horizon and more as a pressure beyond walls, a dangerous vastness glimpsed through ports, cameras, and carefully rationed excursions. The city would be on Mars, but much of life would unfold by turning away from the planet in order to endure it. Dust would become one of the most intimate enemies of the settlement. Martian dust is extremely fine, pervasive, electrostatically troublesome, and capable of infiltrating machinery, seals, joints, filters, and living spaces. It can cling to surfaces and equipment in ways that transform ordinary exterior operations into contamination risk. Storms on Mars can range from local disturbances to events large enough to affect the entire planet, and even where winds are not forceful in the terrestrial sense because of the thin atmosphere, dust still matters because it gets everywhere. This would turn the boundary between inside and outside into one of the most important social facts of the city. Airlocks, suit ports, decontamination zones, filtration systems, maintenance areas, and dust control procedures would not be peripheral infrastructure. They would become part of everyday urban rhythm. Returning from the outside would resemble re-entry from a contaminated industrial zone. The city could not afford casual permeability. It would need rituals of separation between habitat and surface. Dust also has a way of degrading optimism. It is one thing to speak grandly about building humanity's first city on Mars. It is another to imagine constant abrasion in machinery, contamination in seals, obscured instruments, clogged systems, and the slow wearing down of a civilization by particles so fine they seem almost conceptual until they begin to break things. Mars fascinates in photographs. In maintenance logs, it may prove exhausting. Cold would be another permanent fact, though its danger is more subtle than the drama of vacuum or radiation. Mars is not simply cold in the way a mountain winter is cold. It is cold as a planetary condition, a world receiving less sunlight than Earth, with a thin atmosphere that stores heat poorly and permits dramatic temperature swings. The first city would therefore depend constantly on thermal management. Heating systems, insulation, power reserves, and habitat design would not merely improve comfort. They would preserve biological possibility. That dependence matters because temperature stability is a foundation upon which many other systems rest. Water handling depends on it. Agriculture depends on it. Electronics depend on it. Human rest and mental stability depend on it. A city on Mars could not casually allow infrastructure to cool and recover later. Thermal failure in one part of the system might propagate into other failures with unnerving speed. The settlement would live in an ongoing relationship with heat as a managed resource rather than a background condition. This changes the emotional texture of architecture. On Earth, buildings often mediate climate. On Mars, buildings would create climate. The city would not stand inside weather so much as manufacture its own weather indoors. Every warm room would be a technical accomplishment. Every ordinary shower, shared meal, and night of sleep would be nested inside an artificial atmosphere and thermal envelope that required continuous energy to exist. Water would rule the city as both necessity and strategy. Mars almost certainly possesses water in forms useful to future industry and habitation, particularly as ice in certain regions and perhaps in other subsurface contexts. But useful presence is not the same thing as easy access. Water would have to be found, extracted, purified, stored, recycled, and protected with extraordinary seriousness. It would be needed for drinking, hygiene, food production, oxygen generation, thermal regulation, and perhaps propellant manufacturing if the settlement aimed at any long-term logistical sophistication. A first city on Mars would therefore not simply need a reservoir, it would need a water civilization. Recycling rates would have to be extremely high, losses would matter, contamination would matter, distribution networks would matter. A leak in a terrestrial city is often costly. A leak in a Martian settlement could be morally and operationally unacceptable. Water would be too precious to waste and too central to treat as a hidden utility. The same is true of air. Carbon dioxide in the Martian atmosphere offers an industrial opportunity, but breathable oxygen must still be produced, stored, monitored, and circulated. Pressure must be maintained. Carbon dioxide inside the habitat must be controlled. Filtration must function. Redundancy must exist. A city on Mars would not merely consume air. It would have to make its atmosphere and keep making it forever. Food turns the settlement from a shelter into a society, yet food production would be one of the hardest tasks it faces. Early missions could rely heavily on imported provisions, but a true city cannot remain forever a glorified warehouse supplied entirely from Earth. Over time, it would need greenhouse systems, controlled environment agriculture, perhaps algae or fungal systems, perhaps cultured proteins, perhaps several overlapping strategies. Each introduces its own demands in energy, water, nutrients, disease management, labor, and space. Growing food on Mars would not resemble agriculture transferred neatly to another planet. It would be agriculture inside an engineered ecology, already dependent on life support infrastructure. Plants would not simply sit in Martian soil under Martian sunlight and begin to nourish a city. Lighting may need supplementation. Soil may need extensive treatment or replacement. Atmospheric conditions must be controlled. Pollination, microbes, pests, fungal risk, nutrient balance, and crop diversity all become matters of continuous intervention. This makes food emotionally different. On Earth, food arrives to most people through economic systems so large that the biological labor behind it becomes abstract. In a Martian city, food would remain visibly tied to the city's technical competence. A poor harvest would not be just an agricultural setback. It would threaten morale, health, and confidence in the settlement's self-sufficiency. The first city would learn very quickly that cuisine is not merely culture, it is also life support with flavor. Power would sit beneath all of these concerns like an unsmiling sovereign. The city would require uninterrupted energy for air handling, pressure management, heating, water processing, recycling, communications, computing, manufacturing, medicine, transport, science, and agriculture. A loss of power on Earth can be severe, but many cities still exist inside an environment where temporary exposure is survivable. A loss of power on Mars could begin a much harsher countdown. Without energy, the city does not merely go dark. It starts to lose its claim to be habitable. That is why any serious Martian settlement would need robust redundancy and a philosophy of energy rather than just a source. Solar power is plausible and valuable, but Mars receives less sunlight than Earth, and dust accumulation and dust storms complicate solar reliability. Nuclear options are therefore often discussed because they promise more stable output, though they bring their own engineering, political, and safety complexities. Whatever mix is chosen, power would not be background infrastructure. It would be a living concern, a civic reality visible in policy, maintenance, rationing decisions, and emergency planning. Every room, crop bed, medical device, and pump would quietly testify to the city's energetic metabolism. Mars would teach its inhabitants that civilization is, in the most literal way, an electrical argument against an uninhabitable world. Then comes the question people often avoid because it sounds too ordinary to belong beside interplanetary grandeur: boredom. A first city on Mars would indeed face danger, but it would also face routine, repetition, monotony, and the erosion of excitement. The first months might be filled with historic intensity. The first years perhaps with disciplined pride. But eventually a city has to endure its own normality. Systems need checking, filters need changing, disputes need mediating, laundry must be done. Children, if they are there, need teaching. Equipment fails at inconvenient hours. Personal incompatibilities ripen. A place becomes real when it is no longer dramatic all the time. That realism could be psychologically punishing on Mars because the environment outside would remain permanently extraordinary, while interior life risked becoming mechanically repetitive. The inhabitants would know they were participating in one of humanity's most ambitious enterprises. Yet on many days, their experience might feel less like epic conquest than like maintenance and confinement. That mismatch between narrative prestige and daily texture could create a peculiar kind of alienation. A city survives not only by protecting life, but by making life worth protecting. That means public spaces, privacy, leisure, ritual, beauty, conversation, art, games, celebration, and the small, unplanned pleasures of ordinary society. The first Martian city would need all of these not as luxury additions, but as anti-corrosion measures for the human spirit. Without them, survival could continue while meaning thinned. Isolation from Earth would deepen every emotional strain. Communication delays between Earth and Mars vary with planetary positions, sometimes stretching to many minutes each way. That is enough to break the illusion of real-time reassurance. Advice can arrive, but not instantly. Intimacy can persist, but not conversationally in the old sense. Emergency intervention from Earth can be planned in theory, but never improvised in the moment. A Martian city would live under the permanent knowledge that Earth is both near enough to dominate memory and far enough to deny immediacy. This is a cruel distance because it frustrates instinct. Mars is not another star. It remains inside the same planetary family. The Earth would still exist as a visible idea, a remembered climate, a source of supply, law, and cultural gravity. Yet the city would have to function with increasing autonomy because time lag and transport lag make deep dependence dangerous. The result would be a strange psychological duality. Mars would be founded by Earth and remain tethered to it, while also being forced to grow away from it in practice. Homesickness in such a place could become historically important. A person on Mars might not merely miss a family or a city. They might miss weather, oceans, the ease of breathing, unfiltered daylight, the smell of plants after rain, the casual invisibility of life support. Earth would cease to be ordinary and become precious. Mars may therefore teach one of the oldest lessons of exile. Distance can transform background abundance into an object of almost sacred longing. Governance would quickly become serious. The first city could not remain forever a mission patch enlarged into a settlement. Once enough people lived together long enough, questions of law, command, labor, fairness, privacy, reproduction, punishment, emergency authority, and ownership become unavoidable. A base can be run. A city must be governed. On Mars, That governance would unfold under conditions where material survival and political legitimacy are unusually entangled. Air allocation, access to transport, maintenance labor, medical resources, greenhouse output, research priorities, and private space could all become sites of conflict. On Earth, even serious political failures are often cushioned by scale, legal plurality, migration, environmental fallback, or simple geographic escape. On Mars, none of those protections would exist in the same way. A bad decision by leadership would have nowhere to dissipate except through the bodies and daily lives of the governed. This does not mean the first Martian city must become oppressive. It means only that governance there would carry a density of consequence rare in terrestrial politics. Institutions would need to be trusted because distrust in a closed system is dangerous. At the same time, power would need restraint because survival logic can justify almost anything if left unchecked. Mars would therefore test whether a human community can remain both disciplined and free while enclosed inside infrastructure that must not fail. Medicine would also reveal the city's fragility with unusual clarity. A Martian settlement would need advanced diagnostics, pharmaceuticals, surgery, or at least trauma capability, sterilization, isolation procedures, dental care, reproductive care, psychological support, rehabilitation, and protocols for dealing with radiation exposure, decompression accidents, burns, fractures, contamination, and chronic stress. No city is mature until it knows how to care for the broken as well as the strong. On Mars, that care would take place under grim constraints. Evacuation to Earth is not a routine option. Specialist supply chains are slow. Equipment failure could compromise medical capacity. The city would need not merely doctors, but medical sovereignty. It would have to decide what risks to accept, what procedures to attempt locally, and what losses to endure because distance makes rescue theoretical rather than practical. This becomes still more difficult when one remembers that a true city implies the full arc of human life. Pregnancy, infancy, aging, disability, and death cannot remain abstract forever. How would children develop in Martian gravity? How would long-term radiation affect reproductive health? What would elder care mean in a settlement where every cubic meter is precious? These are not cinematic questions, yet they determine whether Mars becomes a human place or merely an extended technical camp. If the city grew large enough, identity itself would begin to shift. The first inhabitants would likely think of themselves as people from Earth living on Mars. Their children, or the generations after them, might begin to think differently. The city could become more than an outpost. It could become a birthplace. Once that happens, the settlement acquires a moral gravity distinct from the mission that founded it. The inhabitants are no longer just participants in a project. They are citizens of a place. That transition could be beautiful, but also dangerous. A Martian-born identity might produce resilience, innovation, and local pride. It might also sharpen separation from Earth, create generational tension, and complicate the political relationship between planet of origin and planet of habitation. If Martian gravity shapes bodies differently over time, return to Earth could become more difficult physically as well as emotionally. The city might then stop being a temporary extension and become the beginning of another branch of human belonging. There is grandeur in that possibility, but it does not soften the threat. It intensifies it. A first city on Mars would not merely be trying to survive one mission. It might be setting the conditions under which an entirely new civic identity forms inside a world that remains hostile to unprotected life. The consequences would reach far beyond architecture. Dependence on Earth would remain far deeper and more humiliating than most heroic language admits. Even if the first city learned to extract water, produce oxygen, grow part of its food, and fabricate some replacement components locally, it would still stand inside a material relationship with Earth so extensive that true independence might remain distant for generations. Medicines, advanced electronics, specialist tools, precision parts, certain polymers, highly refined components, industrial catalysts, Medical imaging systems, software support, and many categories of expertise would continue to flow from the planet below. A Martian city might speak the language of autonomy while still relying on Earth for much of the invisible complexity that makes modern life possible. That dependence would shape civic psychology as much as logistics. Every delayed shipment would carry emotional force. Every failed launch from Earth, every political crisis affecting supply priorities, every industrial setback at home, every shift in budgets or public enthusiasm could ripple through the city more intensely than people on Earth would likely understand. A late cargo vessel would not simply postpone convenience. It might delay repairs, reduce medical readiness, defer construction, compromise crop plans, or force hard rationing in sectors that had hoped to grow. A city that knows its vulnerabilities are partly orbital and political, rather than purely local, learns a special kind of anxiety. Mars would not merely test engineering. It would test whether a society can endure knowing that some of its most important organs still lie on another world. There is also a quiet insult hidden in that dependence. Human beings often bear hardship with dignity when hardship feels self-chosen and self-governed. Dependence, by contrast, can breed a subtler frustration. A Martian population working heroically to create its own civic identity might still have to wait for valves, medicines, microchips, or specialized diagnostics launched by a civilization with oceans, forests, and breathable air. Earth would remain visible not just as memory or myth, but as the industrial parent whose abundance still underwrites the experiment. That could generate gratitude, resentment, realism, and homesickness all at once. Waste would become one of the defining truths of life on Mars because the city would be forced to face directly what Earth civilizations usually hide through scale. On a living planet, waste can be transported away, buried, dispersed, diluted, processed, burned, forgotten, or exported into systems too vast for daily consciousness. Mars would allow much less hypocrisy. Human settlements there would exist inside finite envelopes of pressure, mass, volume, and logistical tolerance. Wastewater, worn filters, biological waste, broken electronics, contaminated materials, packaging, expired pharmaceuticals, damaged tools, failed crop substrate, and chemical residues would all remain within a city that cannot afford to pretend disappearance is the same thing as resolution. This would make recycling not a virtue signal, nor a municipal program, nor even merely good engineering, but part of the city's moral metabolism. To throw something away would mean almost nothing in the terrestrial sense because away would not exist. Waste would need to be recaptured, sterilized, repurposed, broken down, stored, mined for components, or turned into feedstock for later fabrication. The first Martian city would have to learn a civilization-scale humility before matter. Every kilogram that arrived from Earth would have been bought with staggering effort. Every kilogram discarded carelessly would therefore represent a civic failure. The psychological effect could be profound. Abundance on Earth often permits a kind of innocence about use and discard. Mars would abolish that innocence. Objects would acquire longer biographies. Clothing might be repaired repeatedly rather than replaced. Domestic goods might be maintained with nearly ceremonial seriousness. Packaging would be designed with second and third lives in mind. People might grow more inventive, more patient, and less impulsive in consumption, but perhaps also more rigid, more anxious, and more sensitive to any behavior that looked wasteful. In that sense, the city's material discipline would not remain merely industrial, it would become cultural. Construction would also be much harsher than most visualizations suggest. A rendered image of a future Martian city often appears finished, with graceful habitat clusters, pressurized corridors, perhaps greenhouses and landing pads arranged in elegant harmony beneath a pink sky. What those images usually omit is the long, violent labor of getting from first landing to durable urbanity. Building on Mars would mean operating in dust, in low pressure, under radiation, inside cumbersome suits or teleoperated systems, with a constant need to conserve power, spare parts, and crew energy. Expansion would not arrive as a natural phase of civic optimism. It would arrive through endless industrial effort. Imported modules could provide an initial foundation, but a city of real scale would eventually need local construction methods. That likely means using regolith for shielding, sintered bricks, compressed structural forms, printed elements, or underground excavation. Every one of those options brings its own chain of machinery, power demand, maintenance burden, and technical uncertainty. Mars will not offer builders the simple advantage of open-air work with bare hands and ordinary cranes. The act of making one room larger, one corridor safer, one storage chamber deeper, one greenhouse more secure would be entangled with a whole ecosystem of support equipment and risk. This matters because a city is not only founded once, it is modified endlessly. Pipes need rerouting, compartments need reinforcing, storm protection must improve. New medical facilities, classrooms, fabrication bays, recreation spaces, and radiation shelters have to be added over time. On Earth, cities grow through layers of ordinary inconvenience. On Mars, growth would be closer to sustained siege engineering. The population would live inside a place that must keep building itself just to become slightly less fragile. Mobility outside the city would also remain more dangerous than the word exploration tends to imply. The Martian surface is vast, visually open, and alluring in orbital imagery, but operationally it would be read through the logic of range, suit endurance, rover reliability, communication continuity, terrain risk, weather uncertainty, and margin for recovery. A hill on the horizon might appear inviting and still be effectively remote. If the route to it requires energy the city cannot easily spend or rescue capacity it cannot safely promise. Distance on Mars would have to be interpreted through life support arithmetic rather than instinct. This changes the relationship between settlement and landscape. On Earth, cities expand into suburbs, roads, industrial zones, farms, and recreational spaces through relatively ordinary transport. On Mars, the surrounding land might remain psychologically near and practically dangerous for a long time. The first city could become an island inside a continental emptiness, with operations extending outward only under carefully regulated conditions. The red plain beyond the habitat would not be public space, it would be exposure. That could shape urban culture in subtle ways. People living in the first city might know the surrounding planet mostly through windows, cameras, maps, and official excursions. Children could grow up under a sky belonging to Mars while still experiencing most of Mars as forbidden terrain. Such a city would possess a frontier all around it, and yet be unable to relax into that frontier as a casual extension of daily life. The land would remain present, magnificent, and withholding. Sleep, timekeeping, and the ordinary texture of days would also require more invention than outsiders might expect. Mars does at least offer a day length not radically different from Earth's, which is one of the quiet mercies often cited in settlement discussions. But the similarity is not enough to solve the human problem by itself. Artificial habitats still determine light quality, soundscape, private space, and the emotional atmosphere of rest. Outside, there is no wind through leaves, no rain against roofs, no bird calls, no distant traffic softened by air, no breathable dawn. Inside, there would be fans, filtration, pumps, regulated circulation, doors, ceiling, machinery cycling, and the quiet background hum of systems that must continue working if sleep is to remain sleep rather than exposure. Over time, the management of circadian rhythm would become part of civic design. Lighting would need to imitate natural transitions skillfully enough to support biological stability and emotional health. Schedules could not be dictated only by engineering efficiency. A city built entirely around task cycles and maintenance windows might keep people alive while making them inwardly brittle. The first Martian city would therefore need to manufacture not just breathable air, but temporal grace. It would need mornings that feel like beginnings, nights that feel like permission to rest, and communal rhythms that prevent the settlement from becoming one continuous industrial shift. This may sound secondary beside radiation or water, yet civilizations often break not only through disaster but through chronic failure to make time livable. If people cannot sleep well, cannot recover, cannot feel continuity between work and meaning, then even the best technical systems inherit a population growing less capable of using them wisely. Mars would punish bad sleep as surely as it punishes bad seals, only more slowly. Education would become a civilizational challenge the moment the settlement stopped being a rotating mission and began to imagine continuity. A true city implies not just specialists on assignment, but people who grow up there, or at minimum remain long enough to require more than mission training. Children, adolescents, apprentices, artists, technicians, historians, nurses, mechanics, and civic administrators would all need different kinds of knowledge. The city would therefore need schools in some form, yet schooling on Mars could never be a thin replica of terrestrial education. Systems literacy would become unusually basic. Young people would need to understand air, water, pressure, radiation shelters, emergency routines, agricultural dependencies, and material limits in a way Earth children do not. The ecology of the city would be too central to treat as hidden infrastructure. And yet education that focuses only on survival risks producing a population technically competent and inwardly starved. Literature, music, philosophy, humor, art, history, and memory would matter precisely because Mars would otherwise pressure the city toward functional severity. This is where the first city would face one of its most difficult balances. It must raise people capable of maintaining an artificial world while also raising people who can imagine more than maintenance. If it fails the first task, the city becomes fragile. If it fails the second, the city becomes spiritually narrow. A real Martian civilization would need both engineers and poets, both technicians and teachers, both repair manuals and stories large enough to help people understand why continuing the experiment remains worthy. Religion, grief, and ceremony would also change their form under Martian conditions. No enduring human community escapes death, mourning, ethical conflict, or the need to place suffering within some shared language of meaning. On Earth, these experiences are held by inherited geographies, cemeteries, rivers, ancestral homes, seasons, churches, mosques, temples, public squares, funeral customs, forests, weather, family proximity. Mars would strip away most of those familiar supports and force the city to invent rituals adequate to an enclosed world. How would mourning unfold in a place where every cubic meter matters and where biological remains may be medically, technically, and politically sensitive? How would communities gather for remembrance when assembly space is limited and labor demands remain relentless? What does burial mean in regolith on a world where contamination, symbolism, and practical necessity may all conflict? These are not decorative questions. They define whether a city can carry human depth into an environment that constantly pressures it toward pure utility. The same is true of celebration. Births, anniversaries, mourning days, memorials, seasonal observances, and civic rites would all need forms suited to Mars. Without them, the city might continue functioning while feeling less and less like a place where full human life is being lived. Civilization is not just systems plus population. It is also how a population marks time, loss, gratitude, and continuity. The first city would have to invent those forms while still fighting to keep its pumps working. There is another danger that receives less attention because it lacks cinematic force: gradual decline without dramatic catastrophe. Popular imagination loves visible disaster: a breached hull, a great dust storm, a fire in a power unit, a shattered habitat window, a doomed rescue. These things are indeed frightening, but an early Martian city might be more likely to face a quieter enemy, one made of small failures, chronic shortages, delayed repairs, social fatigue, lowered ambition, and the slow normalization of compromise. A settlement can remain alive while becoming less healthy in ways that are hard to dramatize and easy to underestimate. Spare capacity shrinks, greenhouse output declines slightly, maintenance consumes more labor each year, psychological support becomes thinner, cultural life contracts because survival work grows heavier, policies become more rigid because flexibility looks too expensive. The city does not collapse. It simply becomes narrower in spirit and more exhausted in function. From the outside, it still exists. From the inside, it may already feel like a triumph reduced to discipline. This form of danger is chilling precisely because it lacks a single decisive moment. No one can point to one day and say that on this day the dream failed. The city just changes texture. Rooms feel more worn. People become less patient. Aesthetic ambition gives way to practical patching. The future feels smaller. The first city on Mars may therefore be threatened not only by a spectacular accident, but by the long erosion of resilience under conditions that never stop demanding vigilance. And still, despite all of this severity, people may go and some may stay. That is part of what gives Mars its peculiar authority over the imagination. The dangers are not hidden anymore. NASA, engineers, mission planners, and many sober advocates of settlement have spent years identifying them in detail. The menace does not lie in ignorance, it lies in clarity. Mars remains compelling even after the list of hazards grows longer, and perhaps partly because it grows longer. Human beings are sometimes drawn most strongly to places that reveal what they require from us. But that should make the script of conquest more modest, not less. The first city on Mars would not prove that humanity had transcended vulnerability. It would prove almost the opposite. It would show that a vulnerable species can preserve itself in a hostile setting only by carrying pieces of Earth inward through technology, discipline, and unending labor. Every breathable room would be a confession of dependence. Every greenhouse would be a reminder that biology must be protected from the planet rather than entrusted to it. Every child, if children came, would embody both a triumph and a question. Mars fascinates because it looks like destiny. It threatens because destiny, when examined closely, turns out to require plumbing, shielding, governance, agriculture, medicine, education, waste processing, rituals for the dead, tolerance for boredom, and the humility to know that one bad valve can matter more than one beautiful speech. That is why the first city on Mars would be terrifying. Not because it would fail to inspire, but because inspiration alone would be almost useless there. The first city on Mars would therefore be terrifying for a simple reason that unfolds into many others. It would ask human beings to perform ordinary life inside an extraordinary danger. It would require them to build homes in a place where the surface itself cannot be home without mediation. It would ask them to found politics inside life support, culture inside confinement, agriculture inside engineering, and hope inside delay. Mars fascinates because it looks like a world. It threatens because it refuses the biological meaning of that word. Its red deserts, ancient valleys, polar ice, dust storms, and silent plains would indeed offer one of the greatest landscapes humanity has ever seen. But the first city would not primarily experience Mars as scenery. It would experience Mars as pressure beyond walls, radiation above shielding, cold outside insulation, dust at every threshold, and distance in every calculation. The settlers would not simply be looking at another planet. They would be negotiating with it every hour. That is why the first durable human presence on Mars would resemble a survival mission more than a glorious conquest. Glory belongs to the launch, the landing, the headlines, the photographs, the speeches, the flags, the first footprints. Survival begins after that, in the long anonymous labor of keeping people warm, fed, sane, protected, and socially coherent under a sky that offers beauty without mercy. A city may someday rise there. If it does, its true monument will not be in the symbolism of arrival, but in the quiet endurance required to remain.